What does it mean, and for what purpose we're gonna use this equation? This is a question for you before I'm gonna start my lesson today for you. So here the cross-sectional area of a wire is equivalent to radical 3 over the conductivity of the wire times the voltage drop times length times Irated times power factor, or in another sense we said that we called it cos theta. So what does it mean, and for what application we are using this equation in our real life system? Many students, many researchers, many instructors in the entire planet of the earth knows so many mathematical equations. But the very first question today I have for all of you is, we know the mathematical equation, but where we gonna apply that equation in our real life system? And we are using our theoretical knowledge, turn this or change into a physical system. When you look this equation, the cross-sectional area of wire is equivalent to radical 3 over the conductivity of wire times the voltage drop times length times Irated times cosine theta, or power factor, is nothing but it is said to be the cross-sectional area of wire. Wire for electric system, wire for the electrical power transportation, wire for the power distribution system. We gonna take a power through this system is said to be wire. You have to know this wire. Wire is nothing but which is takes a power from one place to another place. During that moment, we have to analyze what is wire and how we gonna use right cross-sectional wire capacity in the right place. Many of us in our home consumption, in industrial application, in every power distribution system, we are using a wrong wire gauge. Wire gauge in American numeric system, cross-sectional area in a millimeter square, in some European country, in Asian country, and in our country Ethiopia. We are using this wire in the wrong position. So today in my episode, I'm gonna share you how we're gonna use this application or this equation in our real life system. Let me take you to a brief introduction about this system. What does it mean, this root 3? Root 3 tells about a 3-phase power system. So the 3-phase power system, as you know that power in 3-phase case, let me show you. In power in 3-phase case, we look, power in 3-phase, power is equivalent to, radical 3 or root 3 times, yes, this is power root 3 times voltage times current times cosine of theta, or cos theta. So there is, for a mathematical analysis, we are using this root 3 times voltage times current times cos. By the way, it's not cot, it's cos theta. This is a power factor, by the way. For that reason, we are using this power factor, this root 3 in here. Look, root 3 over conductivity of wire times voltage drop. Why is a voltage drop in here? We are already popular with this term, root 3. Root 3 out of radical, it is equivalent to, by the way, this root 3. Root 3, let me show you in a very detailed way. Take in a pan, by the way, in AutoCAD 2000, in every Autodesk pictures, we are using pan in order to take our design, our scripture from one position to another position here. So here, look, this root 3 is equivalent to 1.73. Take it out of radical times voltage. Voltage is in a 3-phase case. We know that 380 or 400, or in another sense In another sense, it is maybe said to be like 220 or 240, 240, 240 in a single phase case. So we are using this equation, by the way, this term for a three phase case, this equation for a single phase case. We are using a three phase, we are using this radical 3, unless we are omitting this radical 3 and simply multiply voltage times current times cosine theta. Even cosine theta is not present in a case of single case, in a single phase. So we are able to know this mathematical analysis for both a single phase and three phase case. So let me show you only the three phase case. This cosine theta is a power factor which is again multiplied by, as you know, that this power factor is most of the time 0.85, or it may be 0.8, depends upon, by the way. So there is the power for a single phase and a three phase case. In a single phase, we're gonna multiply this thing with only the current and voltage. Here voltage you don't know, this voltage is 220, which is written in here, or 240, times the I current, or I rated here, I rated, I current. So this is in a case of a single phase, this is in a case of three phase. So my today's lecture for all of you is not in order to represent this equation, but my today's lecture is in order to tell you the cross-sectional area of a given wire. Look here, wire. So there are a lot of wires in a wire in a coil. We are not using a random wire for a certain application. There are wire gauges here. Look, let me show you in here, which is a very visible. We must calculate this number of wire gauges, or diameter of wire is taken by this mathematical equation. Look, there are a 4 wires, because which is a 4 gauge wire. So in a 4 gauge wire, I mean that in a 4 wire, which is 3 neutral and 1 neutral and 3 pairs. So those are in a 1 wire coil and a wire in a single insulator. So we cannot use this number of wire in a random application. We are using in a physical, visible mathematical equation, so-called cross-sectional area of wire, is equivalent to this radical 3 time over conductivity of wire. We are using conductivity for copper, for aluminum, for silver, for every element we are gonna use. But basically in every design application, copper have a very accurate and a very suitable conductivity, which is especially used in terms of price, because the right application in every engineering analysis is in the work of cost minimization. So we have to minimize a cost, we must use the copper wire. So as you know that the copper wire from the Russian electrician design book, the conductivity of copper wire is always 56. So we have to take 56 in a place of this conductivity of a copper wire, which is a very important tip, by the way. Let me tell you, let me introduce you what are the very important parameters in order to insert and in order to find the right cross-sectional area of a given load. So before that, you have to know this thing, especially the power, irated power, the power application. Here we have a voltage drop. Voltage drop. Voltage drop is nothing. Last time I'm gonna introduce it for you. Voltage drop is due to many applications, because of temperature, because of long phase. Our system, or our wire, or our cable are able to pass it with the voltage drop. So for that matter, we have to take this number for a load center. If your load center is a motor application, for a motor application you have to use this 5 times the 380 or 400 voltage in the case of 3 phase. When your load center or a load system is other than this motor load, maybe it's a lightning system, as I mentioned in tutorial number 1, maybe a stray lightning system, maybe a school compound lighting system, building electrical installation, for any other related senses, you have to take 3 times the phase voltage. It is maybe 380 or maybe 220 versus 240 voltage. So you have to take these items in order to design and in order to get the right wire gauge or a wire diameter. So this is the conductivity of copper wire, as I told you before, which is 56, especially for copper, which is standard, which is taken from the Russian electrician design book. So use 56. I highly recommend in order to use that number to substitute this conductivity of a copper wire, since your conductor is a copper. Take if maybe your conductor is aluminum, you have to change that number. Your conductor is in a silver. By the way, silver is not recommended because of the initial cost or initial price, but here if you use it in a cross-sectional area, the conductivity of wire, your wire is in a copper, aluminum, maybe silver, maybe lead, maybe gold. It depends upon, but many electrical systems, even if the international electrical engineering society recommend for power distribution system in as well as for the home or building electrical installation and power transmission, except a few application. Power transmission system is better if it is maybe taken as a copper as a conductor. So you have to take a copper conductor, and it's much or which is analogous term for this conductivity of copper wire. The number is 56. To substitute 56 in the conductivity of copper wire, voltage drop is as I mentioned, as I presented to you, you have to take voltage drop 5%, which is 0.05 times 318, which is 19 volts. So 19 volts in a case of a motor load. If your system have a motor load, or the power is taken for a motor in order to rotate some kind of 3-phase or single-phase motor, you have to take that. This is a voltage drop. What about this term L? L represents for a length. This is, by the way, the very important question. If let's say let me tell you, this is a length. Look this number. So this is the initial position, by the way. This is the initial position, and there is the final position here, the final position or the final outgoing or output here. Okay, before that, let me close this thing. This is or maybe this thing. So look, this is your load supply area. If the supply area which is an initial point, let's say this is an initial point, which is initial point, and there is a final point. So you have to measure the length between this point to this point. Look, this point to this point, which is almost 5.7928 meters. So which is, by the way, the very important thing you have to know. So that is this is the power source, and this is a load center. So in between the power source and the load center, we have 5.792 length. So that will be L here. L, this L indicated that from the load center to the power distribution system or the power distribution area. Here the power is distributed from here, and the load center is here. So it is very important thing you have to know. So length is a very important parameter you have to know in determining the cross-sectional area of a wire here. What about Irated? So Irated is a very important thing, the second important thing you have to know in your life. So Irated is nothing which is 2 times power in a kilowatt. So completely you have to convert, by the way, let me share you. By the way, it's a very important parameter. So Irated is it's nothing, by the way. You have to change, first of all, your own load distribution system into a kilowatt or kilovolt ampere. If you got a kilowatt ampere, you have to change into kilowatt. If you got a kilowatt, you have to change into kilovolt ampere. So active power and the apparent power is a very important parameter and analogous term, especially in electrical systems. So you have to know Irated. This Irated is a very important thing. Let's say, let me give you example. 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 Okay. Let's say your load center is in a motor. A motor. Let's say the motor capacity is in a 55 kilowatts. It's a very important thing, by the way. You have to know that if your motor load is 55 kilowatts, if your motor load is 55 kilowatt, you have to multiply this 55 kilowatt with this 2 in order to get the amperage power. So the amperage power is again equivalent to 100 ampere. So this is a very important thing you have to know, by the way. So this is for Irated. If instantaneous current is needed in a case of here, you have to multiply again 1.25 multiplied by this 100, which is equivalent to again almost 125 ampere. By the way, I'm gonna share you the very big difference between this number and this number. So this is for Irated current. This is for this application, but this is the breaker or the controlling mechanism. For the controlling mechanism, we have to able to substitute the breaker in order to on off the system. So your breaker capacity is 125 ampere, but your Irated is 100 ampere. This 100 ampere only is substituted in here. This is not substituted. Don't use, by the way, never use this item or this number in a place of here Irated. So use this number in Irated place, this number Irated place. So use in here and take the power factor as you know that the power factor is mostly from 0.8 to 0.8.5. So there is a very important tutorial, by the way, you have to use in your every installation system. If you are electrician, if you are engineer, if you are a service technician, I don't know wherever in where we are currently working, but you have to know that the exact application of this cross-sectional area of wire. So cross-sectional area of wire is a very important thing in order to understand, in order to do some kind of electrical project. So as you know that it's a very important parameter in order to take a power from one source to another source, in order to take power from one area to another area, so which is a pipe or which is a transportation system. So we are taking a power from one position or from one area to another area. You have to determine those all things: the conductivity of wire, the voltage drop, the length, the rated current, and the power factor are the very important things. So the very important, let me repeat that, the very important thing in order to take power from one area to another area is, first thing, you have to determine the cross-sectional area in a millimeter and in a gauge. Next thing, you have to know about the conductivity of that particular material. The conductor is copper, the conductor is aluminum, the conductor is silver. So you have to know about that item, that particular device, for which kind of material this particular conductor is made. So you have to know, and you have to make analogous with the mathematical application in order to build a very solid project in a certain environment, in a certain smart city, or in a certain community, in a certain office. So this is, by the way, the very important, the crucial thing. I don't know, uh, as I mentioned before, I don't know wherever you are working right now, but this parameter is a very important and a very crucial thing. I hope you all like this item. So this cross-sectional area is the number one parameter. The next thing is the conductivity of wire. The third thing is the voltage drop. The third thing is the length, the total length from the distribution system, or from the power distribution to load center. The third thing is Irated here. The third thing is Irated. Look here. The third and the very important thing is Irated, and the final thing is the power factor. So this power factor, current, rated current, the total length, the conductivity of wire, voltage drop are the very important thing in order to determine a right cross-sectional area in a mathematical application. So in the next episode, I will share you, I will take one solid example and how we're gonna select a right cross-sectional area. By the way, there are so many standards, we are not taken only our design or our figured number, and we are searching for materials in a dealer shop. But before that, where our design, our number may be taken as after this mathematical equation, our number is maybe 7 mm square. There is no 7 mm in the market, currently the market is never ever produces a 7 mm square wire in a shop. So you have to take the tabular standards. There are standards in a design table. So I will share you that thing in the next episode. For here, thank you, by the way, hearing and looking this very solid academic teacher. So I hope you like. If you like that, please don't forget subscribe and give a favor for me. And like, share is a very mandatory in my channel. So thanks for now.